Okay, so to continue, Helen is opening her first savings account and depositing $500. So there's your initial amount. Suppose she decides on a bank that offers 6% annual interest. Okay, make sure you take the percent and immediately translate it to a decimal. Okay, if you don't remember how to do that, simply take 6 divided by 100. You get 0.06. Okay, that's nothing to remember. And then calculate it at the end of each year. So number one wants us to write a function, a of t. That's fine. Usually I use just p of t, or it doesn't matter. They want a of t in this case, equals our initial amount. These are going to be growth. You don't want to obviously put your money into a savings account where it decreases. So the plus or minus is used kind of for multiple formulas. So we have 1 plus the rate to the time. Okay, that's all you're doing with a formula like this. So then if we're looking at the amount of money at the end of 1 year and 5 years, we simply put in 500 times 1 plus 0.06 to the 1, or 500 times 1 plus 0.06, 5 years would be to the 5. Okay? Figure those answers out on your calculator. After 1 year, she'd have $530. It's pretty decent. At the end of 5 years, she has, pending that this is rounding properly. I'm going to double check to make sure, because it just makes me nervous what this book does sometimes. My calculator needs to go on though. Okay, let's try this again. It ends up being 669.11. Okay? So that takes care of how you figure out her account. And 6%, I tell you, is awfully high. You're not going to see a lot of that in many banks. Trust me on that one. Now, it wants us then to determine the amount of money in Helen's account at the end of 3 years if it's compounded blank. Well, this formula now is a of t equals... Oh, I wish I was in the classroom. 500 times 1 plus, here's the major difference, the rate over the amount of times compounded, where in this case it's twice. We're using that formula with the r over n to the n times the t. So the difference is right here, the number of times compounded. So you'll notice, unhighlighted, it's 500 times 1 plus 0.06 to the third. That would be if it's just a regular, straightforward account. But because it's being compounded twice a year, n equals 2. So that's why I put that 2 in there, okay? It's a little intimidating, but it's really not a hard problem. So when you throw that into your calculator, you end up with, $597.03. Okay, I'm making sure, parenthesis 1 plus 0.06 divided by 2. You're probably going to need to put that in parentheses, or actually just use your fraction function. What am I thinking? To the nt. Oops, I forgot a parenthesis, because that is not the right answer. Okay, hang on just a second. Second, insert parenthesis. Now I've got it. You get 597. Oh, they do round and they're not supposed to. Man, am I glad I double checked this. It's actually 597.026, and banks do not round up. It's 0.02. So I was using the book to just give me the answers quicker, and it was wrong. So now it worries me about even the 669.11. 500 times 1 plus 0.06 to the fifth. Okay, the 11 is right from that previous problem. So, but yeah, it's 02. So monthly, how many months are in a year? 12. So here n is 12. So your formula then becomes A of t equals 500 times 1 plus 0.06 over 12 this time to the 12t. Okay, see, that's the only difference, is that number of times compounded. Put that in your calculator, now that I just cleared it all out. 1 plus fraction. Man, I don't know why these buttons are feeling like cement. To the 12 times 3. And you get $598. Oops, I should probably write it in a color you can see. $598.34. The last one is daily. Well, how many days are in a year? 365. So A of t equals 500 times 1 plus 0.06 over 365 to the 365 times, okay, I can stop here, times the 3. And that gives you, give me 1 second to type this in. Oh my God, this is so slow. 365. See, I haven't lost my sense of humor. Everything is still annoying. To the, I shouldn't say that because it's not. 365 times, I'm telling you, my calculator, the keys are like bricks, you guys. It's like I have to push so hard on this to actually get it to work. Okay. Finally. And that's 598. Yeah, see, I'm glad I did this because the book rounds it again. It's 598.5998. They round it to 60, and I can promise you banks don't round. So I will be sending an email to Carnegie today telling them that they are making a big mistake with this, because it does not, whoops, I wrote the wrong number. It does not round up. Nonetheless, besides all of that hassle, you'll see that each of these stay pretty close. You know, a lot of people say, oh, cool, I'm going to have my money compounded daily, and it's going to make such a difference. Well, actually, no, how much did it make a difference by? 25 cents, so you get a quarter. So it's not really much more than what it usually would be. Okay? And then if we continue with that, this is the PERT part of this. Why? It says, suppose Helen's investment is $500 and her account is being compounded continuously. Continuously, it uses E. I would be doing my gestures in class, okay? But continuously means E. So my formula then here is, T is, they call this PERT. the original amount, e to the RT. So 500, e stays e, the rate stayed 0.06, and the time they wanted this to be done in 5 years. Now, when you do this on your calculator, you've got 500. To get the E button, you hit the second key, and then the LN key. That's right in between kind of the 7 and the 4, but to the left of it. So you'd hit second LN, and an E pops up with an exponent. So it sets it up for you. Then 0.06 times 5. Enter, and you get $674.92. Notice compounding continuously in 5 years. 5 years up here was $669.11. But we did it continuously, and now it's $674.92. So you get a little more money. So it just depends on where you're going to put that money. Okay? So that takes care of account growth. We'll deal with as population growth or decay, how many times it's compounded, where that N comes in, and then continuously where you use an E.